So next up, I want to talk about hardware a little bit. Because, wow, we've showed some new hardware over here, but there aren't any Windows 8 PCs yet. We're just getting started with that. A lot of you in this audience are the ones who are going to help us make the hardware and peripherals for Windows 8. But what I'd like to do is invite Michael Angiulo up on stage, and he's the corporate vice president for the Windows planning and ecosystem. And we're going to show you some of the coolest devices and hardware support that's available in Windows 8. We have music.
So everybody wants a Windows PC that boots faster, that has a battery that lasts longer, that has a great graphics, display, visuals, touch, sensors, and fits into the thinnest, lightest form factors ever. Let me show you some of the advancements we're making in Win 8. So Windows 8 supports PCs of the widest possible range. ARM processors, 600 processor servers with 4 terabytes of RAM. Go ahead and fire this one up.
Yeah, Airport X-Ray gave me a hard time with this one.
Yeah, this is an enthusiast system that's built with AMI firmware. It's kind of an extreme system. But the last time I did a boot demo was when we launched Windows 7. We had an Acer that booted in 15... see, it's almost faster than the monitor can turn on. That's UEFI fast boot. That was a full cold boot. That wasn't Hibernate. That wasn't anything.
It actually... Most of the time, we're just the fan spinning up on this thing.
It can start faster than the fan sometimes. And it's not just reserved, like UEFI performance isn't just for big, crazy, powerful systems. This is the PC that you blogged about in the boot performance blog. And when you see it start up, you see that you don't have like BIOS screens flashing like DOS characters and stuff. 8 seconds. This is an in-market shipping today PC.
This is a Windows 7 PC.
It's a Windows 7 PC in market today, but UEFI is really important because it's not just about speed and having a boot that looks better, it's about security too. So I'm going to boot this PC, except I'm going to do it from this infected USB key. This has got a rootkit virus on it, which is a really nasty piece of malware because you boot from it and your machine would be owned before any software-based security could possibly keep up, but not with UEFI. I'm going to put it in here. Say boot from USB. And you can see it booting. Probably see it flashing. Boom. That's it. Invalid signature. And so what happened was UEFI checked the boot volume. It had been compromised. And now I'm going to turn this off and turn it back on, and it'll be right back to normal. This is just one of the security features that we have in the product.
Yeah, there's tons of security features. Like if this machine also had been using BitLocker, then you can't even rip the drive out and use it in other places. So a full range of security software. In fact, one of the things that we've got in Windows 8 is we've taken Defender and we've actually built a whole new range of protection all the way up through anti-malware, antivirus. All of that is built into Defender should you want to choose to use it, or you could use your own security software. But when I showed you that working set earlier, that 281 meg, antivirus was running in there as well.
And this is actually an encrypted drive while it's running, so the security's everywhere. So it's good stuff because all Windows 8 PCs will be faster and more secure as a result. And there's a whole new class of Windows 8 PCs that are going to come into existence based on the new advancements in SoC hardware.
Yeah, and so like the job of OS is really to abstract out all the hardware for you so that you can take advantage of all the unique hardware. And as I said earlier, what we really want to do is make sure that the unique value of each hardware also shines through in Windows, whether it's graphics cards or system on a chip or any of the hardware. And so we've got some cool demos of some ARM hardware here.
The ARM and SoC hardware combined. This is a Qualcomm ARM reference design. This is the one we showed at Computex. It's an 8660 Snapdragon. It's hooked up to this debugging system here that's measuring power really accurately. And what's going on this monitor is you can actually see the amount of power being used. It's very low. The system's not off. It's in a new power state called connected standby, which is a really low power idle state. You can see these little spikes that show up here. What's going on is Windows is coalescing all of the timer requests and all of the network requests, turning the radio on briefly, updating the apps, and then shutting the radio back down. So when I turn the system on, it turns on with one click, well, or two, depending on if you have demo gremlins. The system's on. You can see the power jumps right up. It's an instant on type scenario because it was never off. I can interact with the system here, and you can see the power kind of changes as we're rendering and we're drawing on the screen. And then when I go to turn it off, I click it. Immediately the power drops down. What's going on right there is the apps get a chance to pack up their data, and then it's shutting down, and then it immediately drops back to idle. That's the kind of system. Yeah.
I mean, so when we talk about fundamental performance, that's what we're talking about. We're actually taking the things that you experience like in phones, and we're bringing that to the PC architecture at the base kernel level.
And it's one of the things that all of these SoC systems will be able to do. If you go to the Understanding Connected Standby session, you'll see the same power demo running on the NVIDIA Tegra 3. We showed, like, it was 9 months ago at CES. So the first time we showed ARM booting at all. And all it could do is like just boot Windows 8 up to the desktop and like one touch.
Yeah, I mean, it was just like a motherboard demo.
We've made a lot of progress since then. We've got everything running here. We've got fast graphics, the kinds of apps that Julie was running. They're all the exact same apps. I can go back to the beginning. I can launch another app.
So stick-to-your-finger touch running on this prototype hardware.
Yeah, it's fast, it's performant. They're the same build of those apps running here, the same build of those apps running on this TI system. This is an OMAP system, a 4430. And for the first time, no one's seen this one yet. This is an Intel system. This is an Intel 32-nanometer Atom-based SoC development vehicle. I don't know if they're working on the name yet, but they're working on the power.
Yeah, I mean, it's so cool. Our partnership with Intel is great, and we're really excited to be able to show you that the progress that they're making on all of this kind of low-power work as well.
From SoC to high-power systems. I have a couple high-power systems here, too. So that performance thing is at both ends of the spectrum,
yeah.
Tiny systems and enthusiast systems. So this is an HP enthusiast system. It's called the Phoenix. It's going to be announced later this week, the full specs. Obviously, it's just announced now. But what I've got here is a USB 2.0 3.0 demo. So this has 2 drives inside of it. The one on top that I have open is USB 2, and the one on the bottom is USB 3. Now, I'm going to copy a 1 gigabyte. I'm going to select and copy. Sorry, I've got to stay out of the way of the camera. A 1 gigabyte file here, and you can see the new progress indicator. And while that's copying, I'm going to grab a 1 gigabyte file from my USB 3 drive and show how much faster USB 3 copies. So that's like...
And we built this in. This is built in with a class driver, so you don't have to worry about finding all the drivers. We've done a lot of work to make sure that this works everywhere.
It does, and it works on all kinds of systems. I mean, this is a 3 terabyte drive that I put into that system. Windows 7, you could boot from up to a 2 terabyte drive. Windows 8, you can boot from a 256 terabyte drive, which, like, it's like science fiction or something.
Yeah, I got one of those in the back.
Well, you know, the reason that that's actually important is because while this drive seems enormous, it cost me less than $150 to buy and drop into that system. So these things are going to be coming soon. Another system that's a little bit extreme is my DX11 graphics system. I love this thing.
This is great. This is like ice over here.
Well, it's not like ice. It's like lava, actually, up top. Because what I have is I have 3 NVIDIA GTX 580s, DX11 graphics card, 3. They're linked together, they're running in SLI mode, hooked up to all the water cooling. But what this system is capable of doing on DX11 is turning about 700 watts of electricity into about 4.7 teraflops of computing power.
How many teraflops is that?
So it's like a woodchuck chuck.
Yeah,
if you remember that giant Cray supercomputer, like the XPM or something.
Yeah, like with the big tower and the
nitrogen and stuff. It would take 2,500 of those supercomputers to do the same amount of processing you can offload to those graphics cards. It's actually...
And it's just Windows.
It's just Windows running on. But that sounds crazy, but it's actually useful. With the Direct Compute API, you can offload any kind of massively parallel calculation, scientific calculation, modeling, all to that. And
research labs are filled with machines like this.
Sure, and dorm rooms, because they're also awesome for the most unbelievably realistic and violent games you have ever seen. This is a technology demo here. This is a technology demo from Epic. It's using the Unreal Game Engine, which is all DX11 powered, and this camera doesn't do it justice at all. If you get up really close to that screen, you can not only see incredible levels of detailing, but the physics are all rendered in real time, and the whole rest of the world that's off camera is shown in a reflection in his eyes.
There's like smoke. The thing is unbelievable.
It really is. It really is amazing. You can see the wireframe for the tessellation. You can really understand the power of the graphics. But what's really important with Windows 8 is because DX hardware is so prevalent in the entire ecosystem, we built all of Windows 8 on a hardware-accelerated graphics platform. So the reason that the UI is fast across this whole line is that everything has hardware-accelerated graphics, including the apps. So you write a Metro-style app, it's got graphics.
Right, all the transitions, all the graphics, all hardware accelerated,
yes.
Which we started in IE9.
Yeah.
And really baking that into the platform at the native code.
I think they like that.
Sounds good.
Hardware accelerated graphics, no extra work, just write the app, and it runs from ARM all the way up to a system like this. Now, there's another place that we are working with the ecosystems around displays. So one of the things you might notice across all of these displays is that they've got touch and they're widescreen. So first, let's talk about touch for a second. When we were at Computex, I did this demo where I showed first pixel sensitivity. You know, you've seen this on all-in-ones, you've seen this on tablets. That's how the Windows UI comes up. Because what we wanted to do was get to the point where Windows only had to reserve 1 pixel around the boundaries to activate all of the UI. And so that left more area here for the apps to take control.
So I wasn't quite clear. You don't get every single pixel. We do reserve 1 pixel around the whole edge.
Off by 1.
Off by 1.
Typical developer error. So there's more about touch that you can learn at these sessions. We have tools and we have tests, and I'll show you one of the tests that we run back in Redmond, where we're working with partners to make just the touch sensor glass go a lot faster. Here, Stephen, you can pick this guy up for the camera. I'll give you the robotic finger.
This is the robotic finger.
It's a finger that's attached to a robot that goes and touches the glass in very specific places that we know about randomly and tracks motion. And this is a PC board that has a clock that's synchronized with the clock on the PC. Let me show you how it works. So go ahead and touch that to the screen.
So this is my robot finger.
Yeah. And what's going on is it's sampling at over 100 times a second. It runs for about 10 seconds. It collects a bunch of data, knowing where we touched and knowing where the screen responded. And because it's testing the hardware, it takes all of the software variables out of the equation. And we get a bunch of log files and important data that our partners use to make better touch hardware. And that benefits everyone because touch is across such a wide range of systems. You have to be able to trust that it's good to write an app that uses it. Another place that you notice these displays in common, they're widescreen. I mentioned that. We're working with display vendors on trying to make the best possible experience for Metro-style apps on next-generation displays. Now, the important thing to know is if a screen can run Windows 7, it can run Windows 8 desktop apps 100% of the time.
So 100%. So all that compatibility, even down to 1024 by 600, all your desktop apps continue to run on Windows 8.
Which was even below the system requirements.
It was, yeah.
But we run on it anyway. But what happens is if you go to 1024 by 768, you get Metro-style apps. If you have at least 1366 pixels across, you can do that side-by-side app stuff that Julie was showing you. And if you have 1366 by 768, you get all of the Windows UI with no compromises, and that's independent of aspect ratio.
Right. So we work on all, 16 by 9, 16 by 10. As long as you have 1024 by 768, Metro apps run. And as long as you have 1366 wide, then you can get the side-by-side snapping.
Right, in any form or shape or size. So we talked a little bit about the touch sensor. There are some other sensors that Windows 8 both supports and exposes to developers. So this PC has a 3-axis accelerometer, it's got a magnetometer, and it's got a gyro. And you need to use all 3 of those in combination to make an app that responds like this. Let's see if you can. It's just a very simple steering wheel turning app. But what's going on? That's exciting?
Yeah.
Well, I'll show you what's actually exciting about that app, is that if you were to write code to try to combine the output from all 3 of those sensors yourself, you'd be time synchronizing the data and then doing math. It's complicated, but we've got a sensor fusion API, a single API that combines the output of all of those sensors to connect to those sensors and get the full orientation. It's 3 lines of code. That's Visual Studio, 3 lines of code.
Again, part of the Windows runtime works across all the languages as well.
It does. There is another sensor I want to talk about, which is the Near Field Communication Sensor, or NFC. So Julie showed you sharing between 2 applications and how powerful that is. We have tap-to-share scenarios between 2 PCs, too, and it's based on an antenna. In this case, it's in the back of this PC. I can take this tagged card that goes to the build website. I put it here. I can touch the notification. Did that show up okay? And then you can go right to the build website. So whether it's interacting with objects or interacting across PCs, NFC is also exposed, and there are some sessions that show you how to take advantage of that.
That card had an antenna in it, and it is the NFC card.
There are a lot of other devices, too, that require software to really completely experience. Today, whether it's a sensor that's inside the PC or an external peripheral like a printer or webcam, you have to write a lot of software. And it's not always software that you want to write. It's got to have its own installer, its own updater. And most importantly, it has to find a way to go in sync with the Windows UI, either trying to replace it or kind of run alongside it.
These are these applets that come on a system, and there's a control panel, there's a notification tray, there's things in the start menu, things on the desktop, all just to get your device to work. And so we've really worked hard with the ecosystem to improve that situation.
Right, we want to make those apps Metro-style apps. We want the functionality, but we want customers to be able to have unified notifications, easier distribution for you, and full access to the underlying system, including integration into the UI. So I'll show you the first example. This is a Microsoft webcam, one of our HD webcams, and all of our HD webcams are going to ship with these new device apps. So you saw Julie before change her user tile, going to the webcam app.
Now you can see this is a little difference between Mike and Julie here.
Not flatter and light. But because I have a device app, I can go here to where it says more options, and I can see all of these special effects that come included. It's tracking my head around. And then there's my user tile. Now, the thing that was cool there is that it was right in the UI, right where you expected it to be. You didn't have to go to a second place. You didn't have to find it. Smoothly integrated, and it's a Metro app, so you get all the rest of the benefits of that platform. Another example is this a printing app. So I have a simple app here that will print out a paper airplane that we wrote just to show this. I go to Devices, and when I go to print to this HP printer, they created a device app. So I get the standard print experience. I go here to more settings, and finally you can get all of the control of your printer right from within print. You don't have to go to a special place, you don't have to go anywhere else, and
there's an opportunity here.
There is. The opportunity, if you go into their full version of that app, you can see your ink cartridge is low, here's where you can buy more ink, here's where HP as a partner can show off their own cloud printing services. So the full opportunity is there, it's just done with as much work as Antoine showed to write one of these apps. One of the places where these device apps becomes really, really helpful is with connectivity.
Yeah.
So if you have a 3G PC today, you probably have a second connection manager that you have to manage, and passwords in 2 places, and the bars don't even match. So now you can create a Metro-style app to do device connectivity. So this PC that I've shown you is on AT&T's 3G network.
So it has a built-in 3G card.
It does.
That is connected up right now to AT&T.
At the very top, you can see it says connected. I'm trying not to have it glare. When I touch it, I can get some information that auto-populates, 5 megabytes in the last day. View my account, there's a link right above it, and turning sideways. And what that does is it launches that full AT&T app. And so that app shows me all of my data, it shows me all of my personal info, and I can go manage my account. But check this out. The same exact PC I have here with a European SIM in it. So this is a Vodafone account. But of course, Vodafone is European, so here it shows AT&T but would be roaming. Now, I don't want to connect on a roaming network just to do things like see my account balance or top up my minutes. But I can go to view my account.
Because we've worked a lot, so because that sticker shock is really a bad deal.
You don't want that surprise. So here is the Vodafone account where I can click top up and I can go get more minutes. And what's really cool here is all of that communication was done using a network protocol called USSD. So it's a sideband frequency that does all of that connection without making an IP data connection. So that didn't roam, and I could buy minutes and do all of that, all from within the app.
Awesome. And within all the Windows runtime, we've done a bunch of work so that you could roam to Wi-Fi internet cafes, all seamlessly. So there's a lot of work built into that connectivity, which is abstracted out for your developers.
Yeah, it's abstracted out for developers, and it's one of the places where developers working together with hardware partners can really differentiate their experiences right in line. Another place where our partners are doing some really cool differentiation is on new PC form factors. So I've got 3 PCs here. These are all Windows 7 PCs. They've been announced. You can't get them yet. They're shipping soon. Intel calls these Ultrabooks. And the reason they do that is because these are PCs with a full core-powered processor in a super thin and light package. So each one of these things is really amazing. Here's an example. This one will resume from sleep as fast as you can open the lid. This one that Steven's holding, go ahead. This is really a sharp PC. This one that Steven has is all aluminum. We showed this one for the first time in the Microsoft keynote at Computex. It's brushed on the bottom. You can get
these are super thin.
They are thin. These are good PCs. Here's another one that's pretty extraordinary. This is a Toshiba. This one is made out of a magnesium alloy honeycomb space frame inside.
Wait, say that again.
It's engineering for cool.
Okay,
it's a super light, it's super stiff, it has no flex to it. When I close this PC, feel this.
This is
under
awesome.
2.5 pounds.
It's like nothing.
Yet it's absolutely
super rigid. Actually, this is super cool. This is what the folks at Toshiba did. It's actually thinner than the RGB and RJ45 connectors.
Yeah, level that. They actually have to bump out. It's thinner than legacy connectors. It's amazing. The reason PCs can get that thin and that good is because of the new levels of integration that are going on at the motherboard level. So I'll take one of these Samsung PCs you've seen so many times, open it up, which I opened before, take out the battery, but what you'll see is that the battery is actually bigger than the computer. These things are now mostly battery. On this one simple card, I have a full power PC. That's a Core i5, 4 gigs, big solid state disk, integrated 3G wireless WAN, all of the sensors, and something that's like the size of a couple of playing cards. And that's what you would see if you opened up these PCs. They're now just mostly batteries. One tiny integrated motherboard, and you have the entire Windows PC.
Wow, we are just, the work that our OEMs are doing is just incredibly cool. I mean, in all of these different form factors, and all of these are going to be great Windows 8 machines. And that's one of the most important things about what we're doing in terms of being able to support the broadest range of types of scenarios and form factors for computing.
It's both because of the investments that our OEM partners are making and because of closer cooperation with us. So, of course, you've seen this. I don't know if you guys like it. I'm hoping to get one. This is as quiet the room has been all day. This is a PC that we made together with Samsung. They invited us into their factories. We started with the shipping Series 7 design, and we did a bunch of work together. We worked with a partner called Atmel, who works on the touch controller and the display kind of integration. We worked with AT&T and Option to do the 3G module. We worked with ST Micro to do the sensor fusion package. We worked with a lot of partners here, and as a result, we've got BIOS that posts in 3 seconds. It's worked from AMI, a super thin power adapter. And this PC has been really useful to us internally as we've been developing Windows 8.
Wow, how many of them did they make?
Well, I was told it's not polite if you don't bring enough to share. So I got 5,000 in a warehouse next door.
Wow. Bye. Okay, that was a little bit fun. So, we call this the Samsung Windows Developer Preview PC. This is a super interesting PC for you guys. Actually, we're going to give them away in 7 minutes, the first 100 people. So, no, don't do that. Later today, there'll be signs up, all that kind of stuff. But this is a PC for you, developers. This is a PC that will allow you to experience a Windows tablet and a development platform at the same time. Now think of how cool that is. You're building an app, you're trying it out, you're laying on the couch, you're trying it out, and then you hit a bug. Well, what do? You just go into Visual Studio and you debug it right there on that machine. And you can do that because it's running a second-generation Core i5 in that tiny little package. It's got this awesome Samsung Super PLS screen. When you see it up close, you're going to be blown away. It's like at 170 degrees, you could see everything on that screen. The folks at AT&T have done an amazing thing for you. They've included 1 year, 2 gigabytes a month of 3G access with this device. And as Mike rattled off, it's got UEFI, it's got 4 gigs of RAM, that's so you could run Visual Studio, it's a 64 gig SSD, it's got an array of sensors. It's got all the 3D sensors and also the near-field communication sensor. It's got a USB port, a full-size USB, a micro SD port, a micro HDMI port. It supports the pen because it has a pen digitizer. Also, something that you might not be able to see is right over here, it's got a dock. And that dock, you just pop it in and it's charging with the same charger that you could use mobile. And that dock has a USB port, so you could attach a mouse and a keyboard. It's got external HDMI with a full-size connector, so you could run dual monitor from this machine. It also has Ethernet ports, so you could remote debug it. It's just, and all of that is in an 11.6-inch diagonal, 909 gram, 12.9 millimeter package. It's a machine for developers. Now, what is it loaded with? It's loaded with the developer preview of Windows 8 for you to use. So think of it this way. You've got developer preview software with developer preview hardware. You can use the platform and develop on it at the same time. The image on this machine has all these sample apps and SDK apps you've seen. It's got all the tools that you saw Antoine use. And it also is imaged with what we call our recovery environment because, well, this is a preview. And so I'm going to talk a little bit about recovery, but it's a whole new way to restore your machine to the pristine new state that you're going to receive it later today. So I hope you enjoy that. It's a pretty cool machine, but it's a real way to experience the developer preview of Windows 8.